right, so let's look at a mechanism of reaction with water. So our acyl chlorides can react easily with the weak nucleophile water to make a carboxylic acid, so converting that functional group to a new one. And why does this happen in the first place? Well, our acyl chloride is one of our most reactive functional groups. One of the main reasons for is you have a strong electron withdrawing group in chlorine. So you have a dipole between carbon and oxygen, and that creates a more positive carbon atom here, right? So that's attractive to nucleophiles. You also have a strong dipole between carbon and chlorine. And even though chlorine has lone pairs, it is a weak resonance electron donator, so it can't really share its electrons through resonance like, say, an oxygen atom could with our carboxylic acid. So it's only really withdrawing. So you've got pulling electrons away to chlorine, pulling electrons away to oxygen. You have a very positive carbon atom there, very attractive to nucleophiles. So even a weak nucleophile like water can go ahead and react. So that's exactly what it'll do. All right, nucleophilic addition to the polar carbonyl bond. Right, your water is added here, so it's still an unstable intermediate. Most likely, second step here is for that water that's attached now to give up its extra proton to the solvent, back to another water in solution. Right, now we're part of the way to where we need to go. Hydroxides on there, chlorine, right? So then we've had a proton transfer after the nucleophile added. Eliminate the leaving group and reform the carbonyl. And that's our mechanism for this one. The slow step in this reaction is the nucleophilic addition. Proton transfer between the attached water and the solution, right, or another water in the solvent happens pretty quickly. And then the last step, elimination of the chlorine group, is also fast. So this is our slow step, but then proton transfer happens pretty quick as the next step as well. But that's our overall mechanism for acyl chlorides reacting with water. It would really be the same mechanism for acyl chlorides reacting with alcohols, and that's going to be really similar to the reaction of anhydrides as well. It's going to follow the same steps.